Yes, we're good to go. Sure.
Okay. Okay, so Team AutoMagic, Devin and Sonu working on object segmentation. Um, okay, you can see the screen now.
Yes, yes.
Okay, let's try this again. All right. So we're using mask RCNN. Here's kind of a small diagram of what's going on. It's looking for regions of interest using this region of interest align, which they've found to be actually 10 to 50% better than some previous models. And then it runs it through some convolutional layers, also outputs each class has a box and provides the segmentation of all the regions of interest. So that's kind of how it works. Our first step was using mask RCNN with the Cityscapes data set. So we forked this repo for the mask RCNN, and then explored some of the files. They have some good notebooks that help get you started. So there's this demo one which kind of shows what it does, and then train shapes shows training on some different data, and then inspect data helps you make sure that your data is getting to the model correctly. So lessons from exploring the model. There's lots of different pieces to this GitHub repo, so it took a while and had to go through many lines of code and different files trying to figure out how the code was functioning. One key that I think is really important is just, if you're not sure what something is doing, print the output, see what's coming out, and also what type of objects being output there. And so especially when you're trying to input your own data into a model, you need to know, is this a dictionary, is this a list, things like that. Second part, talk with your team. So I was struggling. I was only looking at a couple different notebooks, and then Sonu suggested I try looking at that third notebook, which was the inspect data, and that really helped me figure things out. And that's why I call him Super Sonu. So, yep, talk with your team. They can help. It's good to have a fresh set of eyes on something. And then the last part was pay attention to imports. This repo has a lot of object-oriented programming and custom objects they created, so it was important to see what they were importing and how that was being used throughout various scripts. And so in the end, it was those custom objects really helped to actually minimize the amount of code that we needed to write and allow for easy customization. But it did take some time, like I said before, to figure out what each part was doing. So the next step, we needed to create a mask, basically an array just showing the segmented part of each image. So we had the JSON files showing the polygons. So the first just needed to navigate to the JSON file, which we could do by altering the path of the image file a little bit. So that's what we're doing here, opening the JSON file, and then this is a short example of one of the labels. Many of them are much longer, depending on how many points the polygon had, but we iterated through each one of those, and also here we needed to just change the formatting. It needed tuples of each of these points, so just did a quick list comprehension there. But this image and image draw from the PIL library basically do that. This image just creates an array of zeros, same height and width as our image, and then this image draws ones, or changes the zeros to ones for the outline and the fill of the polygon. So that was actually a very useful, quick way to make each mask, and then each mask got appended to the master list of masks. So here's kind of our output. So you can see this is the mask that they did for the road building. So this building here is this building right here. Vegetation, there's a tree here, for example. Tree. So this is showing multiple different masks for each vegetation that they saw. But all those were created individually from that JSON file I just showed in the previous step. So here's some different examples, different random images of the road, and some of their different annotation masks, instance masks. So this is just something they had built in that's also added bounding boxes around the segmented images, and it just applied different colors to the masks. I want to look into applying a consistent color for things that are the same, like all the cars I think should be the same color. But for right now, this is how their script works. So I will have to search through and figure out where the colors are being set there. I think they're just random for right now. So here's another image of that. This one has more people in it. Next step was to train the model with our Cityscapes data. So we began with using the Cocoa weights, using some transfer learning, so it could be faster. Cocoa already is already very good at identifying things like people and cars, so it's good to use those weights. The training, it takes a long time given the size of the images, so especially Cityscapes images are high quality and detailed. And yeah, they're 1024 by 2048 pixels each, so very, very large images. So each step took about 17 seconds, roughly 3 hours per epoch. So I was only able to run it through one epoch, but the current loss is 2.4571 right now. And after training this model some more, then we can use that as kind of our transfer to what I should be able to learn more quickly. So here's kind of the output of after one epoch. Here's our original image, and here's the output. You can see the segmentation looks pretty accurate. I think it's pretty good, especially after not too much training. The bicycles look pretty good. But there's still a lot of things that it's not doing yet. Obviously, we had roads, sidewalks, buildings, all as part of the annotation, and it's not confident enough in that yet. Here's another example. So it's picking up people very well. Actually, this one, it's very difficult to see these people in this image here, and it's doing a very good job identifying them. So that's quite impressive. Traffic lights, it's picking up some of the time. There's one there, didn't notice. And then there's still some issues going on. I'm not sure what's there, but the segmentation looks pretty good on cars and people. So with more training, I think we'll see some major improvements there. So next steps, we'll just do more training and try to get that loss down even more, but it will take a while, and then we can apply this model to our video data and see what it's looking like before we try and use this to train from our own data. So thank you.